So thank you everyone for attending our conference and sticking throughout the day. It's been a wonderful set of presentations. I've been listening to all of them, and I'm probably going to be referencing quite a few as I start going through my slides. So the topic for today is going to be essentially the announcement of Reversing Labs open source rules. That's going to be at the very end, but until we get to that point, I'm going to explain, how do we use YARA at Reversing Labs? How do we get to this point? And what do we generally think about creating YARA rules? Why do we create them, and who are they generally for? So that's going to be kind of the brief summary of what we're going to go over in the next half an hour. So even though Rob has nicely introduced me, I'm just going to mention a few things that I've worked on in the last couple of years. One of those things is going to be really relevant to the talk itself. So as Rob mentioned, I'm a chief software architect at Reversing Labs, which means all sorts of things Reversing Labs is developing go through my hands and are being monitored by myself. The major project we're constantly working on is called Titanium Core. Titanium Core is our automated static analysis and decomposition engine, which means that it's analyzing all sorts of file formats, that it's trying its best to unpack them, and more importantly is using YARA throughout all of its processing capabilities to generate matches and enable analysts and threat hunters to apply their threat hunting and threat detection rules. There's other components to these particular software. We have Titan Engine, which is our portable executable parser and rebuilder. We generally use that whenever we need to parse portable executable files, when we need to write them packers for portable executable content, and so on. And we have a few other projects that I've worked on in the past. We have the Nix engine, which is our steganography analysis tool, which is looking for hidden content in archives. And in my previous life, before Reversing Labs actually became a company, I created a software packing mechanism, which was called RLPack, RL standing for Reversing Labs. So kind of like a predecessor before we actually became more than a one-man show. So moving on, we're going to talk about how we actually use YARA at Reversing Labs. And I've created kind of like a short little summary about, all the major milestones that we had throughout its years. These are more so you can understand how did our thinking about YARA evolve over time, really. We really started in 2013, which at that point, YARA was already a popular open source project. There was a lot of people using YARA, but they're predominantly been using YARA to do threat hunting. So at the time, kind of like you were using YARA to write threat hunting rules, you would apply those rules and try to do threat hunting on things like VirusTotal in your private collection and so on. At that point, we started integrating YARA into our workflows, but unlike other people at the time, we decided to go with threat detection. Threat detection kind of better fit our use case scenario because people that we work with wanted to be able to accurately detect threats, and they wanted to expand the capabilities that we were providing at the time. YARA at the time was really, starting to become a universal language that people are using to exchange even IOCs between themselves. As soon as we started using it, of course, as any open source project, they were happy enough to receive our contributions. Most of them were related to kind of like performance, ironing out some bugs, and so on. We continued that throughout the years. So there was kind of like a period where we were just kind of happily absorbing the latest version, not really thinking much about how to improve the YARA experience within our product. But then, in 2016, we started to get requests about, well, can we do more with YARA, right? And then we started thinking about how do you actually make the analysts' jobs a lot easier? So how do you, enable them to do what they do best. And you heard throughout the day today that people are, creating systems, they're creating rules, and they need a good way to keep track of these versions. They need a way to make sure that the current version of the rule is actually matching everything it's supposed to be matching. They want to be able to revert to the previous set of rules that work better, and so on and so forth. So we started thinking about this and creating a really natural way to design and deploy rules within the platform itself. And it's kind of like a milestone. And I don't know if this was a trivia question before. At the time, .NET and hashing modules became available, and we just started to integrate them and started to use them as part of the threat detection logic. In 2017, something really interesting happened with our line of thinking. As I said, up until this point, we were mostly focused on threat detection, right? You would write rules to detect threats. And usually those would result in malicious classification. Whatever you would detect, if you choose to do that, you would say, well, this file is malicious. More and more people became really interested into this concept of threat hunting. And when you're doing threat hunting, well, not everything you detect is going to be malicious. Some of those things are going to be interesting for further manual analysis. So we added an option to say, well, it might not be outright malicious. It might be something to take a look at. So it became available that you can actually tag files as suspicious as well as another classification outcome for a YARA rule match. Something really interesting happened in 2018. We started to enable people to write file format signatures directly through YARA. So you'll be able to kind of create a file format signature which says, and natively integrates with the rest of our platform to says something like, this file is packed with a runtime packer and this is the packer name. This is a new archive format that you guys don't really support just yet, but I wrote an external tool that I can use through your platform to extract content from this particular archive format. So this became a really nice and easy way to extend the capabilities outside of just threat detection and threat hunting into file format identification and even unpacking, to just using YARA as a method to do just that. In 2019, we said, okay, so whenever there's a match to the threat to the file, we will declare that as a threat. But it would be really nice if YARA rules were able to fully name the threat itself, right? So you heard just Moshe calling out poison ivy. So really wanted to say to people, okay, so if you write a rule which detects poison ivy, we want you to natively name that threat as poison ivy so that can appear everywhere in our interfaces and your metadata as such. So that becomes a really pivotal point for the rest of the presentation, as all of the threat detection rules we will be releasing are using this kind of logic. So whenever there's a match, we want to be able to present the users with the best possible rule. And the final point for 2019 is a really small one. People who have worked with YARA internals, and there's been a few other speakers that have done so, I know that this is a really simple define. It's a hard-coded limit. But the point of extending YARA to more than 32 threads is just saying we started to be able to deploy YARA on a really nice set of hardware, which can run multiple YARA matching instances at once. So 32 threads became too limiting. And I think that's a nice point in time when we're starting to process large volumes of data. And more than 32 threads becomes the norm for the data centers we're using and all of the other things that are using our engine. And just like a teaser for what's coming in the rest of the year, we have recently started to contemplate how can we best help analysts write good rules. And we have a really good set of features in mind when it comes to creating YARA rules automatically based on the samples you have that have nice comments, so you can actually understand the logic behind creating the rule itself, and quite a bit of backend logic to verify that the rules we're creating are actually going to work, they're going to generate less false positives than you would with other automatic generation methods. So look for that throughout the year. I think that's going to be a really nice addition to all this thinking about YARA that we did over the last couple of years. But moving ahead, right? So what types of rules did we actually decide to create and why, right? There's really two options when it comes to writing rules. You can either be writing threat detection rules or threat hunting rules, and then you make that decision or just go with the both based on the goals you want to achieve. So quickly to summarize, threat detection goals are accurate malware detection and blocking malware threats from entering the environment. Well, for hunting, they're proactive analysis and detection. So you want to be ahead of the threats instead of trying to keep up, basically. So both of those have their own pros and cons. For detections, pros are you can accurately detect malware threats if you create a sufficiently well-crafted rule, which doesn't yield many false positives. You can block malware based on either its code content or the artifacts it creates. Both are really nice options, and those rules can be deployed to scan either files on disk or contents of memory as well. So you can deploy them quite easily in many different scenarios to both detect and do blocking. For threat hunting, the idea behind it is if you create a loose enough rule, you can always find interesting things to analyze. And as Moshe was saying, they're interested in Swift codes which are relating to JPMC. That can be a nice threat hunting rule. So whenever there's a notification of somebody using that particular Swift code, he would get a match and he could analyze whether or not this is sensitive data or something to look at. And you can create a really broad rule. So that rule can be made to be matching on an email or a document or anything like that, right? With less regard to the actual form of the actual format. If it's encapsulating the message, you can write a nice rule to do so. And those kinds of roles, as Moshe's example, can look for other things than just malware, right? You can look for private information, data leakage, or just, as Vitaly mentioned at the very beginning, he's looking for his own name because malware authors are embedding it every so often in malware as well. So, it's a nice way to think about YARA as well. When it comes to cons for both of them, I only picked two. Depending on how you write rules, there can be more than two, but the major ones. For threat detection, it does take some time to write and test these rules and to make sure they're correct. They're generating they have a very high quality. They're generating low false positives. Testing of that nature takes quite a bit of time. And if you create a sufficiently rigid rule, a strict one, it can be easily bypassed by applying packing or just obfuscation or just even manual tweaks throughout the code itself. So there's kind of like a balance between how accurate the rule you want to create versus how many false positives you want to generate. Generally, the more strict the rule, the less false positives, but it is then easier to break. So you need to find that balance. Well, with hunting, if you create a good hunting rule, right, the number of matches it creates can be quite a bit. And you have to manually go through all of them to understand, what kind of matches did it actually produce, especially if it's, applying those matches on multiple formats. So if it's format agnostic, then you have to be analyzing emails and documents and all that stuff. And it takes quite a bit of time to do that. Usually people then tend to create more strict hunting rules, and then they would get fewer matches, but when those matches occur, they would then be more valuable, right? And obviously they can create a lot of false positives because if you create a loose rule, well, it can be matching on goodware and different unwanted content as well. So we've decided to create threat detection rules because the general idea behind threat detection rules is we want to be able to tell you that something is malicious. We want to be able to tell you what type of malicious something is, and we want to do that with high accuracy. And with those goals in mind, we started to think about how to create those types of rules. And there's 4 different rules that we set for ourselves. And when you think about these rules, they're not to be applied generally across, every single YARA rule writing need. They're really specific to our use case scenario. There's a good example when you're writing software that gets quoted every so often on software development forums. There's a kind of like a NASA internal set of guidelines when it comes to writing code. And they really work for their use case scenario when you're writing something which, is supposed to be executing on Mars, and it has low patch rates and so on. There are strict guidelines. There are people who try to apply those rules and they're really not writing code which runs on Mars. So, think of this like that. There are rules for our particular use case scenario. If they work for yours as well, that's great, but don't try to shoehorn them where they don't really fit. So first idea, always, clean written YARA rules with well-labeled conditions, which basically means, as on the screen, I've taken an example to kind of illustrate the point. Find files, for example, encrypt files, enumerate shares. Those labels need to be indicative to the condition. So you need to understand what is supposed to be matching within the file. So later on, when a couple of months pass by and you've generally forgotten what kind of rule you were meant to be writing, that you can go in back and say, okay, so one of these patterns is broken and I know which one, so I'll go back to the debugger, I'll look for this particular function, and I'm just going to add a new variant for it because other ones are matching. If these were just randomly named, like people tend to do when writing YARA rules, like S0, 1, and 2, then this would be so much harder, especially because of the contents of those strings. And I'll show an example of this in a second. So we want to be matching on unique malware type functionality, right? Why? We want to be able to tell you that this particular threat that we've detected is a specific threat type. We want to do that with highest accuracy possible, meaning as close to zero false positives as possible. And to do that, we really reverse engineer malware families. We figure out their unique capabilities, and we map those back into the actual rules itself. So yet again, those labels become indicative of what the file is actually doing. And if you start reading through these labels, you're gonna get the sense of what the malware is trying to do. So find files, encrypt files, enumerate shares. Well, that sounds like ransomware, right? Even regardless of me showing you the rest of the rule, you can still visualize the functionality and say, this is a ransomware, right? And indeed it is. So preferring code byte patterns over strings is something we generally do because strings can be obfuscated, they can be tweaked, and they're the easiest parts of the file to change. Code, not as much, and especially the way we write patterns, we want to be able to say this is the unique functionality, and therefore this is the code which executes, or it's linked to that particular functionality. And if you've looked at this x86 code as much as I have, and I'm very old at this point, you can do a party trick like this. You can start debugging the rules in your head. You can say, well, enumerate shares, right? Maybe I've mistyped this. What does this actually say? So you can say, okay, so this is push EBP, right? And this is move EBP ESP, and then you have a push, a constant on a stack. Then you have a 32-bit push on a stack. So there's a prefix which says, well, this is probably going to be a move, right? And then you have another push, and you have an arithmetic function, another move, and an XOR, and so on and so forth. So if you create a mistake, it's easier to do it like this because then you can, basically go into your debugger and start matching the byte patterns back to the actual code itself. It's a neat party trick, if I might add. And the final rule, right? The final rule is we want all of these rules to be natively integrated into our platform. So we want to be able to say, well, not only did we detect a threat, we want to tell you exactly which threat did we detect. In this particular case, it is ransomware, as I said before. It is Decrypt, if I'm pronouncing that correctly. And the neat trick with our specific flavor of the rules, even though these rules will work with any YARA, is that we are using tags, tag malicious, to indicate to the engine that the rule should be classifying the file as malicious. But also, as I mentioned before, we also want to name the threat itself. So we want to say, well, this is ransomware, this is specific malware family name, and it has the highest threat factor, if you will. So you can write different types of rules to detect even potentially unwanted applications if you choose to do so, and they can have a smaller, lesser threat factor, so because they're less dangerous to the organization. And if you create a rule such as this, you nicely integrate that rule with our platform, which basically is applying the rules every single layer that it recognizes. So I'll create a graph to illustrate this point, which basically says, well, here's a packed file, and generally, executable files nowadays are packed with something. Typically, at least at the first layer, they're going to be packed with something which is packing both good and bad. UPX is one of those packers. So if you're using a platform such as ours, we would unpack that UPX and again apply the YARA rule and all of our other classification technologies to be able to say if the unpacked file is truly malicious. Machine learning is one of those things we do, and machine learning unfortunately can't tell you that is ransomware descript. It can tell you that this is ransomware. But being more accurate is better. So if you're deploying your rule, or in this case, our rule, to refine that detection, you would basically say, well, both of these detections are true. So it's ransomware to machine learning, and it's also ransomware to a YARA rule. I'll let the engine pick the better name to display to the user. And if you follow the path, it would just say, well, YARA wins because YARA is more specific. So the ultimate verdict is going to be ransomware desecrypt. And that gets applied throughout the whole chain of unpacking back to the original file, which generated the unpacked content, which impact is ransomware. So any rule you write in this particular scenario gets amplified because YARA gets applied at every single stage, right? You get this nice little way to worry less about the formats, worry less about packing, but apply actual rules where they need to be applied. Even though this is an executable example, this will work just well with documents and their extracted images. And we heard before we had those jar files. It really doesn't matter as long as it supports the format. You can apply the rule at any stage. But the rules we design are meant to play well with other solutions as well. So even if you would get to the unpacked file through memory analysis, like a dynamic analysis or memory dumps, you would still be able to apply the rule and generate that match. So even if you're not using our technologies, you can use things like dynamic analysis and so on to get the benefits. But what are the actual benefits, right? The general idea behind the rules that we create is that they yield 0 false positives. That's how we try to design them. And before actually publishing them as open source, as we're just about to, they go through rigorous testing. And this is how they look like before we actually make them into classification rules. There's this little bulbs at the end, which tells you how many malicious, suspicious, goodware, and unknown files they're actually matching. And as you can see, all of them are matching only in malicious content, which is detected through other technologies, which basically says that they are better at identifying the specific malware they're written for. And if the threat detection does not include a name, YARA will refine that name to a threat written on the screen. I mentioned that it plays well with other solutions, and here's an example of how that would actually look like if you're using JoeBox or any other dynamic analysis solution. So quite literally, Joe is applying these rules on different memory pages throughout the execution, and you'll see that here Emotet is detected. I think this is going to be at the second second layer of packing for this particular file. So you can still deploy these rules and enjoy all of the benefits if you're using other platforms as well. And finally, open source rules are now public. There's the link. We've published 128 open source rules up to date. And I'm just going to quickly switch the screen to kind of show you the repository and how that's laid out before we take it out to QA. So you have the basic YARA folder, which has threat type detection folders, so you can go into every single one of them. There's one exploit at this particular time, so we're detecting curveball through YARA, which is a really nice rule you should take a look at. There's one info stealer, which is a POS attack. There's quite a bit of ransomware, quite a few. I'm just going to open one of them, let's say Locker. So you can see get like the idea of how big these spike patterns are and why we feel that the detections the rules are going to be generating are actually going to yield true positives only. All of these are actually human written. We're the guys who actually mask all these things. We do those things through IDA Pro and all these static analysis tools and dynamic analysis tools that we use every single day. So these are not machine generated. There's a few Trojans, as I said. Most of these are on the second layer, so you'd want to be using them to either unpacking, as I mentioned before, or dynamic analysis for best results. And there's a handful of viruses, one of them targeting Linux as well. So these are all free rules. You can apply them in any single scenario that you have today. We've opted off for a really permissive license, which basically just says, well, if you're going to fork the repository and use them, a shout out would be nice, and a copy of the license would be great, but it's just a standard MIT license. So for more details about how we think about YARA, how to create good YARA rules, and so on, I've written a blog, which is either live right now or be live in a second once the team presses publish. But it goes into the details of how to create rules, how to hunt with YARA. I have here nice examples about hunting for packers, how to set up alerts, and all those things. So I think it's a really nice way to talk about how we think about YARA and as well. Yeah. So thank you very much for sticking throughout my talk. I'll be happy to answer any questions you guys have. And stick around after the questions. There's going to be the card which shows all of the answers to the trivia questions as well.
Thank you, Tomislav. We have a few questions. First one is from the crowd. Are there any resources or courses that you're aware of for learning how to develop YARA rules in the way that you're showing?
I think Vitaly mentioned a few. I'm not familiar with his course, I might say, but generally, if you read through the blog, I think it goes into basic details of how we do these things. I think Vitaly and the rest of the gang will be happy to point you in the right direction as well.
Awesome. Next question. I think this will be the last question of the day. Going forward, are you planning on continuing to release new rules with the repository?
Oh, absolutely. I forgot to say. So our initial release is 128 rules. We plan on publishing and updating the repo weekly. So feel free to subscribe, to star all that stuff, and start pulling from the repository. There's going to be new rules every so often. I think we're going to be also tweeting about when we add a significant threat detection rule. So let's say there's a new ransomware out there and we want people to be protected. All that type of a rule, I think, is tweet worthy. So we're definitely going to do that as well.
All right. Well, thank you, Tomislav.